Let us look at proposition number 10 of book 5 of Euclid's Elements. The proposition says that of magnitudes which have a ratio to the same, they both have ratios. A and B have the ratios with C, not the same ratios, just some ratios with C. That which has a greater ratio is greater, and that to which the same has a greater ratio is less. So basically what this means is A is to C. If we take that ratio and B is to C, we take that ratio, then whichever ratio is greater will be the greater magnitude. So here A is to C, and if you look at B is to C, B is to C is a greater ratio. That means B is greater. The other way around, if we see C is to A and C is to B, if these two ratios we look at it, then whichever has the greater ratio will be the lesser one. Okay, so let's see what I mean by that. And remember, if we make this equal, right, equal ratio, then that basically is the previous position. There we were talking of A and B being equal and making sure that the ratios are equal. But here, these ratios are not equal. We are talking of inequality and figuring out which is greater and which is lesser. So we have two cases, one where we are taking the ratio of A is to C and B is to C, and the other part is C is to A and C is to B. So let's take the first one. A is to C, let us say, is greater than B is to C. If we take that, actually let's make it visually more appropriate. So let me make this smaller and this greater. So let us say A is greater, A is to C is greater and B is to C is lesser. Okay, let's take that case. Now let's assume that A is less than or equal to B. Let's assume that. Basically, we are not saying that it is greater than B. We are saying it is not greater than B, which basically boils down to A less than or equal to. Now, it can't be equal. Why? Because the ratios are not equal. Since A is to C is not equal to B is to C, that means A cannot be equal to B based on proposition 5.7. So that means A is to C is not equal to B is to C. So which means A cannot be equal to B. Now let's take the other part of that. Let's based on the assumption A is less than or equal to B. Equal to we have taken care of, it can't be equal. So now let's say A is less than B. That again cannot be correct. Why? Because if we say that A is less than B, then A by C will not be less than B by C based on proposition 5.8. So based on the assumption, both the possibilities are gone. So the only thing that is left is to say that A is greater than B. So that was our first case. Now let's take the other case where we look at the ratios of C to A and C to B and try to figure out which of these two segments are greater based on those ratios. So now here let's assume that B is greater than or equal to A. If we make that assumption, then if B is greater than or equal to A, let's take it one by one. Can it be equal to A? No, it cannot be equal to A. Why? Because if they are equal, then the ratios have to be. And here we are given that these two don't have equal ratios. C by B is not equal to C by A based on 5.7. Now, B is not greater than A. Why? Because C by B is not greater than C by A. On what basis? on the basis of proposition 5.8. So the only choice we have left with is that B is less than A. Basically, if we look at modern algebraic representation of the same thing, it becomes much more clearer. If we say A by C is equal to 3, A by C, this is 3, this is 1, so 3 by 1 is 3. And if we look at B by C, it is 2. So which ratio is greater? A by C is greater. That means A is greater, okay? Now let's look at the other C is to A and C is to B. C is to A is 0.33 and C is to B is 0.5. So here which is greater? C by B is greater. That means B is smaller. That is what this proposition means. So that was proposition 10 of book 5 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share it. That's it for now.